Okay, as we look at our Chapter 3, Review 2, you're going to notice the very first problem. You should look at your review problem. It says that find all open intervals on which the function f of x equals x squared all over x squared minus 9 is increasing or decreasing. So looking at our solution guide right here. So here's our equation right here. So we want to find all those open intervals on which the function is increasing or decreasing. So off to the side over here, I've written down what we need to do. So the very first thing we need to do is we need to go ahead and find the critical numbers. Now as a reminder, the critical numbers of the first derivative set equal to 0. Once we're done doing that, we're going to go ahead and set up intervals using the critical numbers. And we're going to do that from negative infinity to infinity. And then once we're done doing that, we're going to go ahead and test the x values in those intervals to see if that interval is positive, which means it's increasing, or negative, which means it is decreasing. So the very first step we've got to do on this problem right here is we've got to find our first derivative. So to find the first derivative, notice you're going to have to use your quotient rule. So the quotient rule says take the derivative of the numerator. So here's my numerator right here. So its derivative is 2x. Now you're going to go ahead and leave the denominator the same, which is x squared minus 9. Then we have minus, and now we're going to leave our numerator the same. And notice the numerator is x squared. Now take the derivative of the denominator, and the derivative of the denominator is 2x. And then that's going to be all over the denominator squared. So here's my denominator right here, x squared minus 9. So that's x squared minus 9 squared. Once you're done doing that, you go ahead and simplify this down. So to simplify this down, we're going to go ahead and distribute this 2x on through. So I'm going to distribute this 2x on through. So 2x times x squared is going to be 2x cubed. 2x times negative 9 is going to be negative 18x. And then I'm going to go ahead and multiply these two together. So I got negative x squared times 2x is going to be negative 2x cubed. And that's still all over x squared minus 9. So now I'm going to go ahead and take this and combine my like terms. So notice I've got a like term right here in my numerator. I've got 2x cubed minus 2x cubed. And so that's going to be 0. And I'm just going to be left with negative 18x all over x squared minus 9 squared. So there's my first derivative. So now my first derivative, I'm going to find the critical numbers from the first derivative. And remember your critical numbers is when you go ahead and take the numerator, set equal to 0. So those would be the critical numbers of the numerator. So take negative 18x, set equal to 0. Divide both sides by negative 18, I get x equals 0. So there's a critical number right there. I'm going to go ahead and take this denominator, which is x squared minus 9 squared. I'm going to set it equal to 0 and solve it. So I take the square root of both sides, I get x squared minus 9 equals 0. I add 9 to both sides, so I get x squared equals 9. I take the square root and I get x equals plus or minus 3. So those are all my critical numbers. So my critical numbers are 0, negative 3, and positive 3. Now that I've done that, I'm going to go ahead and set up my intervals using those critical numbers. I'm going to go from negative infinity to positive infinity using the critical numbers, and I'm going to go from smallest to biggest. So notice my first interval. So here's my critical number, negative 3. So I'm going to go from negative infinity to negative 3. Here's another critical number right here. So I'm going to go from negative 3 to 0. And now I'm going to go from this next one from 0 to 3. And then I'm going to go from 3 to infinity. So those are my intervals that consist of those critical numbers going from negative infinity to infinity. So now you're going to go ahead and pick numbers inside of each one of those intervals. And so that's what I do. So inside of negative infinity and negative 3, between those two, I get x equals negative 4. From negative 3 to 0, I get x equals negative 1. And from 0 to 3, I'm going to choose a number x equals 1. Then I got x equals 4. Okay, now you're going to take those critical numbers and you're going to go ahead and substitute those into the first derivative and see whether it's positive or negative. If it's positive, it's increasing. If it's negative, it is decreasing. So notice, here's my first derivative right here. So just kind of a reminder, I found my first derivative right here. It is negative 18x all over x squared minus 9 squared. I'm going to go ahead and substitute those numbers in to that equation right there and see whether it's positive or negative. So I've got negative 18 times negative 4, and I've got negative 4 squared minus 9 squared. So notice a negative 18 times a negative 4 is going to be a positive in my numerator. And this being squared is always positive in my denominator. Positive divided by a positive is positive. So that interval is increasing. So from negative infinity to negative 3, I am increasing. Now I'm going to go ahead and take negative 1. I substitute it into the equation again. And notice that negative 18 times negative 1 is going to be a positive. And negative 1 squared is 1, 1 minus 9. It doesn't really matter because this is always positive in the denominator. And a positive divided by a positive is positive, so that is also increasing. So that interval is increasing. Now I go ahead and substitute in this number right here, which is 1. Substitute that in. So notice negative 18 times 1 is going to be negative. And then this is always positive because anything being squared is positive. Negative divided by positive is a negative, so that interval is decreasing. And then on this last interval right here, again, substituting in your critical number, which is 4. So negative 18 times 4, well, that's going to be negative. That's going to be positive. So that becomes out to be negative. So that interval is decreasing. So the answer to number 1 is you've got your intervals. You've got negative infinity to negative 3, which is increasing. You've got negative 3 to 0, which is increasing. You've got 0 to 3, which is decreasing. And 3 to infinity, which is decreasing. Okay, as I look at this next problem right here on number 2. Number 2 just says, find all critical numbers for the function. And then it says, f of x equals x squared minus 2x plus 1, all over x plus 1. So to find the critical numbers, just a reminder, to find critical numbers, find the first derivative, and set both the numerator and denominator equal to 0, and solve. So following my quotient rule, I'm going to go ahead and take the numerator and find its derivative. So the derivative of x squared is going to be 2x, and negative 2x becomes minus 2. Okay, now I'm going to leave the denominator the same, so that's going to be x plus 1. And then remember I got this minus sign. Now I'm going to go ahead and leave the numerator the same. So this numerator, which is x squared minus 2x plus 1, times the derivative of the denominator. Well, the derivative of the denominator is going to be 1. And then that's going to be all over the denominator squared. So now I've got x plus 1 squared. Okay, now I'm going to FOIL this out. Just doing my algebra to simplify this down. And then I'm going to go ahead and set it equal to 0 and solve it. So here's my algebra right here. So notice I've got 2x times x is going to give me 2x squared. Outside is positive 2x. Inside is going to be minus 2x. And then last is going to be minus 2. So when I multiply those together using FOIL, I get 2x squared plus 2x minus 2. And then I got to distribute this negative sign on through. And I got to distribute this 1 on through also. Of course, the 1 isn't going to change anything, but the minus sign will. So notice this right here. When I multiply these two together, I'm going to get negative x squared. And I got a negative times a negative, which is going to make that a positive 2x. And then I got a negative and a 1, which is going to be minus 1. So I multiply that on through. I get negative x squared plus 2x minus 1. I'm going to go ahead and combine like terms. So here's a 2x squared. Here's a negative x squared. So that's just going to give me an x squared. A 2x and a 2x, well, those cancel. But I still have another positive 2x right here. And I got a negative 2 and a negative 1, which is going to be negative 3. And that's still all of the denominator being squared. So now go ahead and find your critical numbers. You're going to go ahead and set both the numerator and the denominator equal to 0 and solve each one separately. So that's what I do right here. I'm going to go ahead and take this numerator, set equal to 0. And notice x squared plus 2x minus 3, I got to factor it. So it's going to factor down to x plus 3 times x minus 1. So when I FOIL that out, I get x squared, you get 3x, negative x, positive 2x, negative 3. So that's factored, set equal to 0. Now set each one of these equal to 0 and solve it. So you get your critical numbers at negative 3 and 1. So I'm going to go ahead and take my denominator, set it equal to 0. So I'm going to take my denominator, set it equal to 0. I got x plus 1 squared equals 0. Take the square of both sides, I get x plus 1 equals 0. And then subtract 1, and I get x equals negative 1. So those are my 3 critical numbers for number 2. My answer is going to be negative 3, 1, and negative 1. So on this next problem on number 3 says I got y, and it says I got equals x all over x plus 3. It says find the relative extrema. So to remind you, find relative extrema, find the critical numbers, and then set up intervals from negative infinity to infinity using the critical numbers. Test each interval to see whether it's increasing, which is positive, or decreasing, which is negative. If consecutive intervals change from increasing to decreasing, then there is a relative maximum between those two intervals. If it changes from decreasing to increasing, then there is a relative minimum between those two intervals. So we've got to go ahead and find our first derivative to find our critical numbers. So here's our quotient rule again. So using our quotient rule, so let's take the derivative of the numerator, which is 1, leave the denominator the same, which is x plus 3, minus, now go ahead and leave the numerator the same, and the numerator is x. Go ahead and take the derivative of the denominator, which is going to be 1. And that's all of the denominator squared. Distribute this 1 on through. So 1 times x is x, 1 times 3 is 3. So I've got x plus 3, and then negative x for this right here. So now I simplify that down, the x's cancel, and I get 3 all over x plus 3 squared. So now I'm going to take that denominator, set it equal to 0. So notice when I set the numerator equal to 0, well, that's just a 3, 3 equals 0, so there's none from the numerator. So there's no critical numbers there. I'm going to go and take this denominator, set it equal to 0, so I got x plus 3 squared equals 0. Take the square root of both sides, I get x plus 3 equals 0. And then I get x equals negative 3. So those are my two critical numbers. So setting up my interval from negative infinity to infinity, I'm using my two critical numbers right here. I'm going to go from negative infinity to negative 3 and negative 3 to infinity. I choose my test points inside those intervals. So between negative infinity and negative 3 is a negative 4. So I'm going to go ahead and substitute that into the first derivative. So just a reminder again, your first derivative up here is right here, it's going to be 3 all over x plus 3 squared. So that's what I'm going to substitute in the negative 4 into that interval right there. So substituting that into that interval, come down here, you're going to see I go and substitute negative 4 into that into that first derivative. So I put 3, then I put in parentheses negative 4 plus 3 squared. Well, this is positive in the numerator, positive in the denominator, positive whatever, positive is positive. So that means that interval is increasing. From negative 3 to infinity, I choose a 0, substitute that in, so I got 0 plus 3 squared. So 3 all over 0 plus 3 squared is also positive, so that's also increasing. So there was no changes between the consecutive intervals. So I went from increasing to increasing, so there are no changes. So there are no relative extrema in that interval. Okay, then on number 4, it says find all absolute extrema in the interval from 0 to 2 pi. So just as a reminder, to find absolute extrema, substitute the endpoints into the original equation, find its value. Then substitute the critical numbers into the original equation to find their value. The one with the largest value is the absolute maximum. The one with the smallest value is the absolute minimum. And note, there may be more than one absolute maximum or minimum. In other words, there might be more than one high point and low point. So this problem right here, I'm going to first find the values at my endpoints. So here's my endpoint at 0, here's my endpoint at 2 pi. So I take my original equation, I'm going to substitute that in. So in place of x, put a 0. And so I'm just now going to take 3 times cosine of 0. Well, cosine of 0, well, that answer is going to be 1. So take your calculator, or you can either do that or just go ahead and type that in your calculator if you want to, or use your chart. Use your calculator. Notice your calculator right here. Make sure that you are in radian mode. And then you just have to type in 3 cosine of 0. And that answer comes out to be 3. Next one I'm going to check on right here. I'm going to go ahead and check on 2 pi. So I substitute in 2 pi. I made a mistake there, but it's still going to come out to be the same. Or sorry, not. I wrote down here a little ways. I didn't make a mistake. I actually put it so there's actually space between them. So I'm substituting in 2 pi. So I'm going to take 2 pi and substitute it in right here. So 3 cosine of 2 pi. Substitute that in. So I take in 3 cosine, type in 2 pi. And that's also going to come out to be 3. So notice I've tested those. Now the reason why I left a space between those two is because I want to make sure that my critical number that I'm testing is going to be between those 2 points. So to find that critical number, I'm going to go ahead and find the first derivative. So to find the first derivative, well, the derivative of 3 cosine of x. Well, derivative of cosine of x is negative sine of x, so my first derivative is going to be negative 3 sine of x. I set 0 equal to negative 3 sine of x. Solve it. I divide by negative 3, get 0 because the sine of x. Take the arc sine of both sides, so I'm going to find the arc sine of 0. So the arc sine of 0 comes out to be, and you can type this into your calculator, you can take sine inverse of 0, which is the same thing as arc sine. You're going to get 0 for one of your answers. But remember, you always have two answers whenever you're doing finding your angles, because 0 is right here, and you're going to notice that the second answer, we either have to take pi minus 0, or we have to take pi plus 0. Because it's a quadrant, it's going to fall right in here. And so that's why you get the same answer of pi. Those are your two answers. You're going around your quadrants. So those are the two that we have to test for. So you're going to notice that this first one right here, which is 0, well, that's also an endpoint, so we don't really need to test it. But we do need to test this point right here, which is going to be pi. So here's pi right here. So here was 0. That's already an endpoint, so I already tested that. And now I'm going to test pi. So I type in my calculator 3 cosine, and then type in pi, and hit enter, and you get negative 3. So now you just compare those three. So that means that the largest, which is this right here, so it's 0, you get 3 as your absolute maximum. So here's an absolute minimum right here, and this one would also be an absolute maximum. And you can have more than one absolute minimum and absolute maximum. Okay, now on number 5, going on this next problem right here. So number 5 says that we have y all equals negative x cubed plus 6x squared minus 9x minus 1. And the directions say find the intervals in which the graph function y equals negative x cubed plus 6x squared minus 9x minus 1 is concave downward. So to find concavity, set the second derivative equal to 0 and use these values to set up intervals from negative infinity to infinity. Test intervals to see whether they are positive, which means concave up, or negative, which is concave down, by substituting values in the interval into the second derivative. So it's very similar to the critical numbers of the first derivative, increasing and decreasing, but now we're going to do concavity, which is actually the second derivative. So I'm going to go ahead and find this derivative. So I got negative x cubed becomes negative 3x squared. Got plus 6x squared becomes plus 12x. Minus 9x becomes minus 9. Of course, negative 1 becomes 0. And so now I've got the first derivative, negative 3x squared plus 12x minus 9. Now to find the second derivative, take this first derivative, take the derivative of negative 3x squared. So that's negative 3 times 2 is negative 6. Drop that power of 1, so that's negative 6x. Derivative of positive 12x is going to be just plus 12. And the derivative of negative 9, of course, is just 0. So now that I have my second derivative, I set it equal to 0. And I set it equal to 0 and solve it. So I got second derivative, negative 6x plus 12, set it equal to 0. Subtract 12, you get negative 12 equals negative 6x. Divided by negative 6x, you get x equals 2. Once you have that number right there, go ahead and set up your intervals. So your two intervals you're going to be seeing, you got negative infinity to 2, and you've got 2 to infinity. Okay, now that you got your two intervals, you got negative infinity to 2 and 2 to infinity, just going to choose a number in those intervals. So I notice that 0 is between negative infinity and 2, and I notice that 3 is between 2 to infinity. So notice I'm going to go ahead and put it into the second derivative because that determines concavity. So when I put a 0 in the second derivative, so remember your second derivative is negative 6x plus 12. So I'm going to put that 0 in there, so I get negative 6 times 0 plus 12. So that answer is 12, so that is positive, so that means that in that interval it is concave up. So from negative infinity to 2, I'm concave up. I'm going to go ahead and substitute in 3 into my second derivative, which is negative 6x plus 12. I substitute in 3, I get negative 6 times 3 plus 12. That's going to be negative 18 plus 12. Negative 18 plus 12 is going to be negative 6, so that's negative, so it's concave down. Notice the question on number 5 is just asking for concavity downward. And so even though I found this one that's concave up, it just wants to know which one is concave down. And so that's why I circled this last one, which is 2 to infinity. It's negative, so it is concave down.